So exercise 54, page 103, question number 7. This one's an interesting to have a look at because of the negative power here. But the same rule applies. So taking the logarithm of both sides and bringing the power down, we get minus 0.25 logarithm x equals the logarithm of 0.792. Dividing both sides by negative 0.25, we get logarithm of x equals log 0.792 divided by negative 0.25. And so we work out what that is on the calculator. So log x equals 0.4051 to 4 significant figures. So x is going to equal 10 to the power 0.4051. But again, I would leave my answer to this part here in my calculator and then just put 10 to the power of that rather than try and introduce a rounding error. So I'd round at the very end. So x to the power 0.4051 should give the answer in the textbook, or near enough. But if you left the answer in there, you get it pretty well exactly. There is another way that you could solve this one, which might be worth looking at, which introduces another of the laws of indices. So let's have a look at this problem again, which is why I really wanted to look at it. So let's have a look at this again. X to the minus 0.25 equals 0.792. You might remember from the laws of indices that a to the power minus b, for example, minus means the inverse. So this would be 1 over a to the b. So we can use that here. So we can think of this as being 1 over x to the power 0.25 equals 0.792. Now we can rearrange this, or we can invert both sides, because if you think about 0.792, that's the same as 0.792 over 1. So if we invert this side, that means we can also invert this side. So we can write that x to the 0.25 equals 1 over 0.792. And now I can work out what 1 over 0.792 is on the calculator. And then I can carry on solving the problem like I did on the first slide, and I should get the same value for x. You might want to carry on with this question and see if you can get that out.